Hey guys, today we're going to start something a little bit new, and it's going to be sequences and series. So before we begin doing specific types of sequences and series, there's some notations we need to learn. So our question today is, how do I find any term of a sequence or the sum of a series? Okay, and you're going to open up your notes book and you'll find these questions in there. Okay, the first thing, this is an example of a sequence. Okay, it's just a list of numbers. It can stop, it can continue going on forever, but this is a sequence. And the thing that we always try to do is we'll write the next couple terms. So we can see right now that this one is just going up by 2 every single time. So to find the next term, I just add 2. To find the next term, I just keep adding 2. Now, if you wanted to find something called the nth term, that's basically a formula. So if they ask you to find the nth term, you want to find the formula that could find you any term inside this sequence. Now, the most important thing to know here is if you're trying to write a sequence, I always kind of make myself the little chart and know that this number, the first number you start with, we always start counting at 1. So this is the first number, so n is 1, this is the second number, third, fourth, fifth, etc. And you're always going to be tempted here when you're finding the formula to be like, well, it's going to be n plus 2, right? Because if I'm adding 2 every time, that's going to get me n plus 2. But if you plug in n into that formula, 1 plus 2 doesn't give you 1, it gives you 3. So this is kind of like finding the equation of a line, okay? So in terms of n, we would say that this formula could be written as 2n because that's the slope of my line, and then I figure out how could I make this first one work, that y-intercept. Well, I'd have to take 2 times 1 minus 1, and that would get me that starting term. And again, you can go through here and figure out this a lot of different ways. The new notation that we're going to talk about is this a sub n, and that's kind of like a y. So this is just whatever the nth term is. Okay, the n is just the term number. Wow, I don't know what's going on there. And I also didn't get that there. And then this whole formula is just how you would find the nth term. Okay, so here's some examples of some sequences that they could give you. It says find the first 4 terms and the 100th term of these guys. And so the easiest thing to do here when you're finding the first 4 terms is just plug it in. So a sub 1, I'm going to replace whatever I see with an n and put a 1 in. So I have 1 over 2 to the 1, which is just 1/2. Okay, and then I do that for a sub 2. Wherever I see an n in the formula, I'm going to replace it with a 2. So I get 1 over 4. Okay, same thing with 3. And you see it's following a pattern. And then a sub 4. And that is 1 over 16. Okay, it works the same way if you have a sub 100. Wow, I have no idea what's going on there. I just can't write apparently. Okay, a sub 100, again, everywhere you see an n, you're going to replace with a 100. And you could try to simplify this, but your calculator's going to have an overflow. It's too big of a power. But that's the idea here. Now this next one is a kind of important one for in the future when we see stuff with negatives. So if I go ahead and I do this the same way, and I say a sub 1, I'm going to plug in a 1. Well, if I have negative 1 to the first, that's just going to get me negative 1. Okay, a sub 2, I'm going to plug in a 2, and negative 1 times negative 1 is positive 1. Okay, a sub 3, negative 1 to the 3 gives me a negative 1, and you betcha if you put in a 4 there, it'll turn back into a positive 1. So this series is what we call an alternating sequence. So if you see that your signs keep flip-flopping, then you have an alternating sequence. And so again, you just plug in and you'd figure out which one, what number it gets you. Now this next one looks almost the same, but what's going to happen here if I plug in a sub 1 is I'm going to get negative 1 to the 1 plus 1, which would get me negative 1 squared, which gets me positive 1. So my sequence is going to look almost the same. It's just now this one starts with a positive. So I'd have positive 1, then negative 1, then positive 1, then negative 1, etc., etc. Okay, so those are called alternating sequences. And so if you see something that has the signs changing, it still can be a sequence. It just means that you're multiplying by negative 1 every time. Okay, the next type of sequence you're going to see is called a recursive sequence. The way we defined the sequences before, that was a direct formula, so I could figure out any term. A recursive sequence is a sequence that's defined by the previous term. So if I'm talking about anything recursively, I have to know something about the term in front of it. So this is an example of a recursive sequence. So it says a sub n equals a sub n minus 1 plus 3. This right here, this is just the term before it. So here's your previous term. And then if they give you a recursive sequence, they have to tell you at least one of the terms. So a sub 1, and sometimes you're going to see this denoted as just a, is your first term. So if I wanted to find a couple terms here, you'd say that a sub 1 we know already. A sub 2, if I replace that in, I'd have a sub 2 minus 1 plus 3. And so we know that a sub 2 minus 1 is just a sub 1. And we know what a1 is. It's 1 plus 3. So we know that the next term is then 4. Okay, and so we'd keep doing that in order to find our next couple terms. And so again, I take the term before it, 1 before it, which would be the second term in this case. And then that was 4, and then I just add 3 to it. Okay, and so a sub 4, I'm going to skip a couple steps. I'm going to say I know a sub 4 should be the term before it plus 3. And so I know the term before it was 7 plus 3. And so you can see every time there's that pattern that's going on. Now the problem with a recursive sequence is it's really hard to find something like the 100th term, because you would have to know the 99th term. And in order to know the 99th term, you'd have to know the 98th term. So with recursive sequences, they're most useful when you know stuff about those. One that you may have seen is called the Fibonacci sequence. And that's basically where you're taking your list of numbers and you add them together, the two in front of them, in case you haven't seen it. And this one right here, when I define it, I would have to give you a sub 1 equals 1 and a sub 2 equals 1. And then your sequence would be defined as a sub n minus 2 plus a sub n minus 1. Oh no, my pen stopped working. Oop, there it goes. And so this is just saying, take those first two terms and add them together. Take those next two terms and add them together. Okay, let's move on. We have the partial sum of a sequence. And so what a partial sum is, it's just saying I need to take up these terms of a sequence and add them together. Sum means to add. So if you see the notation S sub n, capital S sub n, that just means the sum of the first n terms. So let's go ahead and do an example here. I think we already have example 4. I don't know what's going on there. Oh, my pen is just not being happy. So if I wanted to find S sub 1, I would take all the terms, the n terms, the first term, and I would go ahead and add them up. So I know that then I need a sub 1, just 1. So I'll plug in 1 wherever I see an n. And I know that my first sum would just be 5. Okay, now S sub 2, I have to add up all the terms in the sequence. So I'd have a sub 1 plus a sub 2. So that would get me, my a sub 1 would be 5. If I plug in 2 into this, I'd get 7. So S sub 2 would be 12. Okay, and finally our last partial sum, S sub 3, I just take all of the terms in that sequence. So I'd have 3 terms and I add them together. So I'd have 5 plus 7 plus 9, and that would get me to 21. So that's all that a partial sum means. It means add up all the terms up until that number. Now we have a special notation for this, and that is called series and summation notation. So a series is just summing up all of your terms. I don't know if I have a thing here. I don't. So a sequence is actually listing out your terms. A series is just adding them up. And summation notation is something we use to kind of help ourselves out and make this a little bit easier for us to write down, because mathematicians are lazy. So this is a sigma, the big weird looking S. It's a capital sigma. It's a Greek letter. Your a sub I, it's just like a sub n. So this is a sequence, and this is the formula for this sequence. And they could use a lot of different letters. The big thing here is that this letter must match that letter. Okay? This right here, again, I just said this letter can change. They can use X, they can use Y, they can use whatever the heck they want right there. But this right here is your starting term. So this is telling you, you need to start when this number equals to 1, when your letter equals to 1. This top number up here, this n, that's your ending term. That tells you when to stop plugging in numbers. And so all summation notation is it's us being really lazy and not wanting to write out 1 plus 2 plus 3 plus 4 or whatever. So let's do an example. I feel like sometimes it's a little bit easier to see this if you have an example. So I have the summation from x equals 4 to 10 of 2x. So all this is saying here is I want to take the sum of this sequence made by this formula from 4 to 10. So all I'm going to do here is start plugging in at this starting number. And so I'd have the 2 times 4 plus 2 times 5 plus 2 times 6 plus 2 times 7 all the way out until I hit my stopping number. And my stopping number is the one on top. And so it says keep plugging in until you have to 10. And so now at this point, you just could plug this in your calculator or just add it up, and you would find out that number right there. But that's all that this notation means. It says plug in this variable with this value until you get in there, and you're always going to plug in integers. Okay, so on 6 it works the same way. So if I look here, it's telling me that I need to plug in I equals 3 into this formula, and so I'd have that I have 3 squared plus 2, and that's my first term. Then I got to add up and keep plugging in numbers, so I'd have 4 squared plus 2, and then finally my stopping number is 5, so I'd have 5 squared plus 2, and then I just add those up. So I'd have 9 plus 2 is 11, plus 16 plus 2 is 18, and 25 plus 2 is 27, which would get me to 56. Okay, again, these summations should just add up to a number. I was too lazy to do this one over here. And finally, if you're trying to write in sigma notation, so imagine that you were given this and you wanted to go back and draw that sigma notation out so you didn't have to write as much. Here's the steps that you would do. The first thing we have to do is find that sequence formula. And so this one is kind of tricky sometimes. You kind of have to guess and check occasionally, but I notice here that every single one of these has a 3 to the power of something. So if I write 3 to the n, or whatever letter you feel like, and then I'm going to try to make this summation. So I'm going to draw my summation in, and then I used n here, so the n needs to go underneath the bottom. Now I get to decide where I'm going to start, and since I started with a 3 here, I'm just going to put n equals 3. Then I go look and see when I finished. That's the 20, and so I write to the 20 up there. Okay, and so I found my sequence formula, then I found my starting number, and I found my ending number. Now there were lots of ways that I could have written this. Okay, that was not the only option. You could have also been like, well, I want to start at 1. My n needs to start at 1. Well, then what I do is I'd have 3 to the power of, and if I'm trying to make 3 out of this, I would have to take 1 plus 2 in order to get this number for the first number, and then all that would do is change when I stopped. It would stop me at 18 instead of 20. So there are lots of options. You get a choice when you're writing in sigma notation, but that is our intro to sequences and series.